Hello, mathematicians. This is Mrs. Crawford. I'm going to be going over the lesson from Monday, where we talked about SSS, or side-side-side triangle congruence. So before this day, we talked about beginning proofs, how do you write them, what do you need? And when we did that, we didn't give you guys any real shortcuts or any acronyms like we're going to be doing the next couple days. But we did talk about you have to have all the angles and all of the sides labeled. Well, we're actually going to give you some options where that's not necessarily the case. For today, for example, side, side, side means if you know that all three sides of two triangles are equal to each other, you automatically know that all the angles and every piece of the triangle has to be the same. So you don't have to prove all three pairs of angles and all three pairs of sides anymore. You just have to be able to prove enough to get one of these acronyms. So that's your first fill in the blank here. So I'll go ahead and write that in. SSS stands for side, side, side. And what that means, again, is if three sides of one triangle are congruent, there's my symbol for congruent, to three sides of a second triangle, then the entire triangles are congruent, which means all the angles are the same. So down here, if I show that each of these sides are congruent to each other, automatically, once I prove that and I say SSS, that means that these are the same, means that these are the same, and these are the same. Okay, now that's after I prove SSS. I can't use it before. Okay, we're just saying it applies now after. So go ahead and pause and get that copied. First thing we're going to tackle is just getting a couple basics out of the way. Remembering that you always look at the statement. You don't just look at the picture. So if I look at this one, D should match with H. F should match with J, and G should match with K. So looking at our picture, D to H, okay, those are still in the same spot. F and J, and G and K. So we're all in the right spots. Do I have enough to prove SSS? Are all of the sides marked as congruent? Yeah, they are. There's tick mark here, there's double here, and triple here. So yes, all corresponding sides are congruent. Okay, so number one is a yes, it is, and I did explain it, which you need to do. So looking at the second one now, again, check our statement. We've got A should match with C, C should match with A, and B should match with D. And we're referring to each triangle. So ACB, will mark that as triangle 1. This is triangle 1. CAD is this bottom one. So that's triangle 2. So looking at our picture, AB, so AB should match with CD. So let's check that. Does this match with this? Well, this one they don't give us tick marks, but they do give us numbers. And what we have here is a little issue. AB is 3, CD is 4, and they're supposed to be congruent to each other because they're the corresponding sides. Obviously, 3 doesn't equal 4, so that means that AB is not congruent to CD. Okay, so the triangles aren't, oops. Apparently I can't spell aren't. Triangles aren't congruent. Okay, so that I just abbreviated that, but that gives some reasoning, and it says that they are not congruent, and then gives a little bit about why. So let's go into our actual proofs now. Remember we talked about you always start with the given, and you check the picture to make sure they actually wrote it in, because there's going to be a lot of times where that's not the case. So they tell us that KL is congruent to NL. So look in the picture. KL is here. They got one tick mark. NL is here. One tick mark. Boom. That one's already done for us. Don't have to mark it in the picture. They also tell us that KM, which has double tick marks, is congruent to NM, also double tick marks. So awesome. That's already done for us. So given, checked off, written in, awesome. Remember, our goal today is to get all 3 sides marked, and they already give us 2 pairs of sides already done. So check mark, boom. Now we got to figure out the 3rd side. So if I look in my 2 triangles, we'll call this triangle 1 and triangle 2. In the first triangle, what's the only side that hasn't been dealt with yet? This one has a tick mark, this one has double. So LM has not been dealt with. And it's actually the same piece in the second triangle. This green one's done, this red one's done. So this blue LM is the same length in both triangles, which means it has to be congruent to itself. If it's overlapping, if it's the same exact piece, there's a reason we use, what is that called? Hopefully you're remembering it in your head. It is the reflexive, not reflective or reflection, the reflexive property. That property means that if this line overlaps in both triangles, gotta be equal to each other. So automatically it's the same. We've now proven our last set of sides. It's right here. If you want to put like triple tick mark, you can, but it's not really congruent to anything. It's just to itself, so it's not really necessary. But that was our 3rd piece we needed for SSS. They already have the prove statement recopied down here for us. So we just have to say that the reason is SSS, or side, side, side triangle congruence. So actually, we've shortened up the process by giving you this shortcut today. You don't have to prove every single angle like we did before. If you've got 3 sides that are equal, boom, it's done. Gotta be congruent. Before we move on to the second proof, I do want to remind you of a couple things. First of all, what does it mean to bisect a segment? Hopefully in your head you're saying split, or cut, or divide in 2. I think of the phrase cut in half. So think about if we have a segment here, and we call it AB, and I bisect it right there, and we'll call this point C. If I bisect it right there, that means that this piece and this piece are both half, which means automatically congruent to each other. Okay? Means AC is congruent to CB. If you cut something in half, you better have equal pieces, otherwise you didn't really cut it in half. So kind of keep that in mind as we go into this, because look at that, ding, ding, ding. This one has the phrase bisect, so we might want to keep that in the back of our mind. We should hopefully know that the first reason is given. Some are going to write that in, but if you look at our picture, nothing is written in, so we have a little bit of work to do. So first of all, it tells us triangle QRS is isosceles, which means 2 sides of the triangle are congruent. And it actually tells us the 2 sides. That was super nice of them to do. It tells us that QR, so right here, is congruent to SR. How do we mark that sides are congruent? Tick mark. Boom. Now it's done. It wasn't done for me, so I had to do it. That one is part of the given because it's literally written out as QR is congruent to SR. This piece right here, we're going to use, but it's not going to count as the given. So we're still going to have to make a statement at some point to say something is congruent to something else. So far, we've only been given 1 check mark. Ugh, that means we got to figure out 2 pairs of sides that are congruent. So I'm trying to prove this guy is congruent to this guy. So let's start with this bisecting deal. It says RT, so this line right here, bisects or cuts in half QS. Okay, so at this point, what is this point? If this is bisecting us, this blue dot is now the what? Hopefully you're saying it's the midpoint of this line. If it's the midpoint, what does that mean about each side? It means that this segment, Q to T, should be congruent to this half, TS. Why? Why is it congruent? Well, they kind of gave us this big key word here, bisects. If it bisects, it has to cut QS in half. That's the definition of bisect. That's what it means. So it has to be true. So down here, statement number 2, QT is congruent to TS, and it's by definition of bisect. Literally, the word bisect means to cut in half, so it has to be true that those two are equal to each other. Now, we kind of gave you a little hint here. We told you that reflexive property is going to be what gives us that final pair of sides, because we just figured out this one. The second pair is done. So if I look at my picture, let's get rid of some of this excess stuff going on here. Get rid of that, get rid of that. Well, first of all, what's the only side that hasn't been named? We named QR, we named QT. So in triangle number 1, the only piece that hasn't been mentioned is TR right down the middle. If I look at triangle 2, SR and ST have been mentioned. TR again has not. If it overlaps like this one does, see how this side length is the same in both pieces of the triangle? That is reflexive property, just like we talked about before, which means TR is congruent to TR. This is in triangle 1. This is in triangle 2. By reflexive property, they have to be congruent to each other. So that gave us our final S, our final side, side, side. So my last statement is to simply repeat what I'm trying to prove. Remember, this is never a reason. I know given was a reason you start with, but prove is never a reason. Given just means it was given to me. Prove is what you are trying to do. So you can't repeat it. That's cheating. That doesn't work. So I need to put triangle QRT is congruent to triangle RST. And again, the reason is because of side, side, side. I proved 3 sets of sides are congruent here. Boom. Done. On the back side of this page, please be very careful about those first 2 problems. Make sure you check the statement and see if the letters actually match the picture. Don't just look at the picture. In the following 2 proofs, you have all blanks, so you're going to have to fill in a lot of stuff and start getting used to that. Make sure you start with the given and you end with a statement that says prove, and hopefully SSS, since that's what we're focusing on today. If you need any help, feel free to contact or talk to one of your teachers.